Hello, this video is a 1.7 application review. In this video, I will work through similar problems to what you'll see on your application assignment. And just a heads up, on your application assignment, you have 2 attempts. After the first attempt, you will be graded, and then for the second attempt, you'll only have to redo the problems that you missed. And so it can only help your score. All right, so the first 3 questions talk about determining if a point is a solution to a linear equation. We can actually use calculations to determine if a point x comma y is a solution to a linear equation. To do this, we substitute x and y values from the point into the equation and evaluate both sides of the equation. If the calculations results in a true statement, which would mean both sides, where 2 sides of the equation are equal to one another, then the point is a solution. However, if the calculations result in a false statement, where the 2 sides of the equation are not equal to one another, then the point is not a solution. So for example, for question 1, it says substitute the following x and y values into the equation 5x equals 4 minus 2y and evaluate both sides of the equation completely. Show all steps in your calculations. All right, so I'm going to have this, let me rewrite the equation. So 5x is equal to 4 minus 2y, and I'm going to take the value for x and substitute it in. I'll take the value for y, which is -3, and replace it with y, and then I'm just going to evaluate it. So this becomes 5 times the x value is equal to 4 minus 2 times the y value. I like to use parentheses when I'm evaluating, and so I'm going to plug 2 in here for x, and I'm going to plug in -3 for y, and then I'm going to just kind of work it out and see if it makes a true statement. All right, 5 times 2 is 10. 4 minus 2 times -3. So order of operations says I need to do the -2 times -3 first, or I can think of it as 2 times -3. But either way, I would get a -6, or I just get a +6. So this part right here does become a +6. And the 4 would just drop down, so I'd have 4 plus 6. Well, 4 plus 6 is just 10, so this just says 10 equals 10. That is true, which means that is a solution to the linear equation. All right, let's try number 2. It says substitute the following values of x and y into 5x equals 4 minus 2y. So we have the same equation. So 5x is equal to 4 minus 2y. And essentially, we're just kind of performing the same thing here, but we have a new x and y value. So I've got 1 and 4 for x and y. So I'm going to be plugging 1 in for x, and I'm going to plug in 4 for y. And I always like to use parentheses. And so I kind of like to just rewrite it with my parentheses. That just helps me to not make a mistake. And then for the x value, I'll be plugging in a 1, which I'll do in blue. And for the y value, I'm plugging in a 4. And I'm going to see if this makes a true statement. So I'm just going to kind of work it out. This is 5 times 1, which is 5. And then over here, this 2 times 4, or -2 times 4, is 8, or -8, either way. So I have 4 minus 8. 4 minus 8 is -4. 5 equals -4. Okay, that is not true. That is false. Since that's false, that means it's not a solution to the equation, which actually leads me to question number 3. So for question number 3, I'm going to answer some questions about these results. So question 3, the first ordered pair we had, which we could write as an ordered pair, the point 2 comma -3. That was whenever x was equal to 2 and y was equal to -3. That is a solution. When I plugged it in, I got a true statement. Because the calculations result in a true statement, meaning the left side of the equation is equal to the right side. Okay, now when I plugged in the second ordered pair, when I plugged in 1 for x and 4 for y, That is not a solution because the calculations resulted in a false statement, meaning the left side of the equation is not equal to the right. All right, let's move on to a different type of question. This is solving linear equations. Jessica was solving a linear equation and she made a mistake. What step did she make a mistake in, and what should she have done differently? So I'll give you a moment to maybe pause the video and think about what you would do and how you would solve this and where she went wrong. All right, and I would suggest to maybe work it out on the side. So I'm going to rewrite this here. And we did one similar to this in our live session, but I'm going to look at it, and I know first I need to distribute. I need to get rid of those parentheses, so I'm going to use that distributive property. All right, that would be 3 times y minus 3 times 2 minus 1 is equal to, and then I'm going to use the distributive property over here as well. So 5 times 3y minus 5 times 5. All right, that looks good for step 1. Step 1, Jessica used the distributive property. And then we can just kind of clean it up. So this would become 3y, and then 3 times 2 is 6, minus 1 equals 5 times 3y is 15y, and 5 times 5 is 25. And that looks good as well. So we're on the right track here. And then it looks like they combined, or Jessica, sorry, combined her like terms. Negative 6 minus 1, which would be 3y minus 7 equals 15y minus 25, which also is looking pretty good. And then from here, I would subtract 15y from both sides. That would be my next step. And that would cancel. This would become negative 12y minus 7 equals negative 25. And I'm looking, and I can see that that didn't happen. Jessica subtracted the 15y from itself, but she accidentally added it over here. Okay, so that would be the place where it went wrong. And from there, of course, everything else would have been wrong. And so what could she have done differently? I would say that she should have subtracted the 15x from both sides. I'm sorry, the 15y from both sides. All right, let's move on to the next. The next few problems are on properties of exponents, and hopefully you have taken some good notes with properties of exponents. We did have those properties listed in our live session. So for the properties of exponents, we're just trying to figure out which property of exponents was applied. So from this step to this step, what was applied? And I want to point out that the exponent on the x is like a 1 here. And notice that we distributed that 3 to the top and the bottom. And so if I'm thinking about which property that is, and I have different properties to pick from, I want one that has a fraction, for sure. And then I really need it to be raised to the power, because one of our properties is this, that if I have AB raised to the m power, it's A to the m over B to the m. And simply put, the m is going to the exponent on the top and the bottom. And I think that what people could make a mistake on, so I would just say be careful, is that some people see that it's a fraction, and so right away they might want to use the one that looks like this, where we subtract, but that's not what happened. And so I would just say be careful on a problem like this. Let's try another one. We're still using properties of exponents, and we're trying to figure out which property is being applied here. And I'm looking closely at this, and I want to decide what property was used. And you will have a list of properties to choose from. So one thing that I do notice is how does it change starting here to here to here, right? And so one thing I notice is I do see the negative exponent, And but we don't really do anything with that negative exponent. Not to say that that won't be taken care of at some point. But since they're asking us which property of exponents is being applied, I do want to take a look at this 7 minus 4, because that is kind of the operation that's happening. And I notice that I have a fraction, right? And so I would be looking for the fraction 1, but this time it is similar to that property that some people would mistakenly put on the previous problem. And that is what's happening, because if you look closely, we have x to the 7th on the top and x to the 4th on the bottom, and that operation is subtraction, which is a direct application of that quotient of powers property. And then it becomes, of course, 3, because 7 minus 4 is 3. Well, let's move on to one that's a little more challenging. This next one actually asking you which two properties of exponents are being applied here. And this time I did provide the list, because I think a mistake that sometimes students make is they only list one property. So I wanted to really emphasize two. So you're gonna try to figure out which two properties of exponents are being used here. And so if I look at this closely, I notice that I have two variables. I have x and y, and that would be considered like an a and a b, because it can't be written as a since they're two different variables. And so I'd be looking for something with a and b in it. So my first instinct would be this one. And I can tell that that is correct, because you'll see that the exponent of 5 is actually going to go to both parts, right? So I have the 4 to the 5 here. Sorry about that. And I have 8 times 5 here. So that 5 is going to both of those. So that one for sure is being used. And then next, I noticed that we're using multiplication on my exponents. And so that would be looking at each of these pieces kind of like individually. Well, I am multiplying. And so that would be this property, right? Because I would have 4 times 5, which becomes 20, and then 8 times 5, which becomes 40, right? And so that those would be the two properties that I noticed are being applied. Let's move into a different type of question. And this will be similar to the questions you're going to see on your application assignment that are the word problems. And in our live session, we talked about certain words that help us know what operation to use. We also talked about when we use parentheses and when we don't. For this first one, I have the sum of 9 times a number and 12 is 25. The sum of 9 times a number and 12 is 25. And I want to point out a few more things, because I should have highlighted this maybe in a different color, but that's okay. And I have sum, which means plus. I have times, which means multiplication. I have is, which means equals. Now, the sum of 9 times a number, okay, 9 times a number, and we're just going to let x be our number, be a number. The sum of 9 times a number, and then because it's sum, I'm going to put a plus, and 12 is 25. 9 times a number. And then for the second one, we have 4 less than the product of 8 and a number is 12. This time we have less. That is going to be minus. The product means multiplication. And of course, is means equals. So I have the product of 8 and a number. 8 and a number. The product of 8 and a number would just be 8 times x. And it's 4 less than 8 times x is equal to 12. Now, the next two are a little different. This time, I'll highlight this in red. I have 8 times the sum the sum, 8 times the sum. See, before it was 9 times a number, or the product of 8 and a number. But this time it says 8 times the sum of a number and 6 is 20. Well, times, of course, just means multiplication. The sum means addition. 8 times, but because it's the sum of a number and 6, I actually need to make sure that I do x plus 6 in parentheses, because I would have to find the sum of the number and 6 before I get to multiply it by 8, because it does say 8 times the sum of a number and 6 is 20. So before, like on the first one, it said 9 times a number. This says 8 times the sum. Very similar to this last one, 5 times the difference. 5 times the difference, not 5 times a number, but 5 times the difference of a number and 4. 5 times the difference of a number and 4. So I have to do x minus 4, and then I would get to multiply it by 5, is equal to 13. And you're just identifying it where you're not actually solving it, you're just identifying the word problem with the expression, or the equation that it matches. All right, I really hope this video helped you. I hope you do well on your first application assignment. Please reach out if you need anything. I hope you have a wonderful day. Bye.